I'm looking at my formula sheet. So everyone see the formula sheet in front of you, the blue paper. Everyone see it. You get this during your milestone, during your finals, during everything. You guys see where it says average rate of change on your sheet? And it literally tells you what to do, right? It says the change in y divided by the change in x. It tells you exactly what to do. You always get that. What's across from it? What formula is right across from it on the sheet? Slope formula, right? So it literally gives you the slope formula. You get this. They're not going to say, hey, Steven, time to use this formula sheet, right? You're going to need to know, hey, the average rate of change, I know I need to use that formula. They're buddies. They're next to each other. So the first thing I do is I need to put it into table and figure out what the coordinates are. These are your x coordinates. We need to find our y coordinates. So, Carlos, what did you get for the y coordinates at first point? 1, 6, and then 2 what? What do you? 1, 2, 2. What was it? 2 and 12. Yep. Cool. Then how do I find the slope formula? I look on that blue sheet and it says, oh, the slope formula is y2 minus y1 over x2 minus x1. So when you label, how do I label these points? What goes right here, Tyree? When I label.
Label?
Yeah.
Y2.
Is this my x or my y coordinate?
No.
Your x, right? So the x1, y1, x2, y2. So that's important when you label it, make sure it goes in order. The first x, the first y, the second x, the second y. So then when I plug it into my formula, I literally just go, okay, what's y2? 12. Minus my y1, which is 6, over x2, which is 2, minus x1, which is 1. And then you can put that right into ND on your calculator, or you can do it by hand. What is 12 minus 6? And 2 minus 1? 1. So what's my slope, my rate of change? 6. Who got that?
Yeah.
All right, so then you do the same thing with the next one. We already know what 2 is. 2 was what? 12, and what's 3? 24. Okay, Tyreek, how do I label them?
X1,
Yeah.
Y1,
Good. X1, Y1, X2, Y2. And then you plug it in the slope formula. So I would put 24 minus 12 over 3 minus 2. What do I get when I do that? What's 24 minus 12? Good. 12, 3 minus 2. So I end up getting 12 for the second one. For the last one, I do the same thing. I know 3 is 24. You already found that. God bless you. What's 4? 48. Beautiful. David, how do I label them? How do I label my points? What do I put under this? What's this one? Beautiful. And then I plug it in that slope formula. What do you end up getting? 24 over 1, which is 24. Cool. Did everyone get those answers? Now, are those numbers that we just got, those are 3 rate of changes for the same problem. Are they the same number or different number? All 3 of those. Are those 3 the same number? 6, 12, and 24? No, right? And so because they're not the same number, that tells me that it's a variable rate of change. Constant means it's going to be the same. So I'm going to have a variable rate of change. Variable means change, right? So I have a variable rate of change because it's different each interval. So it's a variable because it's a different rate of change depending on the interval. Make sure you write that down. So today we're going to be basically doing this for all 3 different functions. There's one function that has the same rate of change no matter what. Has a constant rate of change. Which type of functions have a constant rate of change? We learned about three. We learned about quadratic, exponential, and linear. Which ones do you think have the same rate of change no matter what? Which one? Which rate of changes between the three do you think have the same no matter what? Linear, quadratic, or exponential? It is linear. Linear has the same rate of change no matter what, because in linear, what does rate of change mean? Or in general, slopes, right? So when I'm doing linear equations, your slope, no matter what, is always your rate of change. So no matter what, linear is always going to have the same rate of change. The ones that are going to be variable are the quadratic. I would write this down on here. Quadratic and exponential. Because they're going to depend on the interval. So those two have variable. That means they change depending on the interval. The only one that's constant is linear, because it's your m of your y equals m. It's supposed to be. Cool. All right, so go to your notes for today, which are this. So we're just practicing. None of this is new again. We're just practicing rate of change using a graph, an equation, and a table. So make sure you're focused. Make sure your phones are away, especially while we're going over these lessons, because your milestone is less than 3 weeks. So you want to make sure you're going to get a good grade on that, because it's 20% of your grade. So they want me for all three of these to find the rate of change over the interval 0, 2. 0 and 2 are is that a point right there, 0, 2, or what does that 0 and 2 represent? Who can raise their hand and tell me what does 0 and 2 represent? Maybe look on your ticket inventory. It's your what? Now you're slow. Like when we were doing it in our ticket inventory just now. What did that interval represent? The x coordinates. So this interval right here means over these x coordinates. I don't want you guys to get confused. I think that's a point. If it says an interval, that means those two are the x coordinates. So they want you to find 0 and 2 on this graph. Find the y coordinates. 0 and 2 on this one. And 0 and 2 on this one. So you're finding where x is 0 and x is 2 on all three of those. Now, one of those is linear. Which one is linear? F, G, or H? Which one looks linear? G. Do you guys see how G is linear? Because it's in slope-intercept form. What is my slope there? 3. So no matter what, my answer should be 3 for that one. My rate of change should be 3 because that's my slope. It's always going to be the same. I can still sit here and put it into table and find the points and find the slope, but it's going to be the same answer. These ones won't. So over here, I need to go to my graph, and remember, x falls on this line. So at 0, I would go down right here, and that's where my graph lands. What is that y coordinate right there for the graph? It's on your paper. What's this y coordinate when x is 0? -4. Then I go to where x is 2, which is right here. Tristan, what's that point? Right here. All right, so who can tell me when x is 2, what's our y? 0. So right here, I would go 2 and then 0. Then you would find the slope. So I want you to, real quick, find the slope of those 2 points. You know how to do it. So you label, and Damon and Tyreek already told us how to label it. And then we plug it in the slope formula. just a reminder, like Ms. Thompson and I are happy to help you too, like throughout the lesson and things like that. But we want to see that you're writing the notes down and you're following along. Like that's what we ask for. So if we see that your paper's blank while you're just sitting there, like we aren't going to help you. You gotta show us you're putting in some effort. Tyreek, what did you end up getting when you plugged it in the slope formula? 2. Did everyone get that answer when you labeled it and plugged it in? Perfect. So I got 2. Then over here, I find it on the table. So when x is 0, up, there's the y. What's the y coordinate? 6. And when x is 2, here's the y coordinate, 3 over 2. If I put that in my calculator, it's 1.5. So now find the slope of that third one. You can still keep it as a fraction and use NP to put it in your calculator. It just might be a little bit easier to just type it right in. When you do that, what do you end up getting? What do you end up getting? Beautiful. Negative 2.25. Cool. So I'm going to go down here and I'm going to write down these rate of changes. So it says f of x is 2. We found g of x is 3. And h of x is negative 2.25. Now, when we're looking at what rate of change is the greatest, what that means is which slope is the steepest. So maybe draw an arrow and write steepest. When we're looking at that, we ignore the sign. We ignore the negatives. So like if we're looking for the greatest rate of change, you don't even look at that negative. You pretend it's not negative. The negative just means it's a negative slope. So which one is the biggest? We have 2. I'm going to rewrite them all positive. 3 or 2.25. 3. So 3 is the largest out of all the positive values. So I know that g of x has the greatest slope. Does that make sense? Then the next one says which ones have variable rate of change. So that first one, does that have a constant or variable? What type of function is it? Is it quadratic, linear, or exponential? Quadratic, right? And we've said before that quadratic's always variable. So we're going to write quadratic, so it would be f of x. What about g of x? What was that one? Linear. So if it's linear, does that have a variable or a constant rate of change? Constant. So we know that g of x will be constant. And then h of x, we looked and we did this yesterday with tables. If it's going down, it's taking half each time. I know that it's going to be exponential, and I know that exponential is variable. So I'm going to put h of x right here. Does that make sense, finding rate of change from a table, a graph, and an equation? So if you're given an equation, always just put it into a table in your calculator. All right, so the next one, I'm going to lag behind you. It's the same thing. So there's 4 practice problems. What I'm going to do is I'm going to lag behind you just to make sure you're right. And then the last 2 we'll have you do for classwork for today. So the next one is, so go to the next page where it says 5 to the x minus 2. The next one on here, perfect. So you're going to be doing this one, and first finding the rate of change between the intervals 0 and 2.